Section 10.4.7. To test the null hypothesis where the population standard deviation is equal to 3.2 versus the alternative where the population standard deviation is not equal to 3.2, a random sample size of n is equal to 15 is obtained from a population that is known to be normally distributed. Well, the first thing we need to look at is when we look at the alternative, we see not equals. Well, that should automatically tell us that this is going to be a two-tailed test. Okay, now if the sample standard deviation is determined to be S, which is equal to 3.6, we're going to compute the test statistic. So what we need to do is first determine, okay, what are the values for n, which is a sample size, which is 15. We know that our population standard deviation from our null and alternative is 3.2, and from part A, we know that the sample standard deviation is 3.6. So now let's go ahead and plug that in. So we know that we have 15 minus 1 times the sample standard deviation of 3.6 squared divided by the population standard deviation of 3.2 squared. So let's go ahead and plug that into our calculator. So we have 15 minus 1, which we know is 14, times 3.6 squared. And then we're going to divide that by 3.2 squared. So now we get the following test statistic. So we're going to round that to 3 decimal places. So we get a test statistic of 17.719. So therefore the test statistic is going to equal 17.719. Okay, so now that we know the test statistic, in part B, we need, it says that the researcher decides to test this hypothesis at the alpha equals 0.05 level of significance, determine the critical values. But the reason why there's critical values, we're going to have 2 of them since we know that it's a two-tailed. Okay, so the first thing we need to determine is the degrees of freedom. We know the degrees of freedom is taking a sample size and subtracting 1. So we know we're going to take 15, subtract 1 to get 14. Okay, now in part 2, okay, what do we know? We know that alpha is equal to 0.05. And we know that we need to take alpha and divide it by 2. So we get 0.05, and we're going to divide that by 2, which gives us 0.025. So what do we need to know? Well, we need to know that the critical value on the left side is going to be 1 minus alpha divided by 2, which we know is going to be 1 minus 0.025, which means we get chi-squared with an area of 0.975. Okay, so we're going to be able to determine what is that critical value by looking at the chart. Okay, so we have our area of 0.975, and we know that our degrees of freedom is 14. So that's going to give us a left critical value on our distribution here of 5.629. Okay, now we need to find the second critical value, and that is on the right. And we know again that's alpha divided by 2. So therefore alpha divided by 2, we got 0.025. Okay, so again we're going to use the area now of 0.025. And we're going to use the same degrees of freedom. So we're going to scroll to the right here. And we can see that we get the critical value there to be 26.119. So those are our 2 critical values. Okay, so now we need to draw the chi-square distribution and then depict the critical region. So here we're going to draw our chi-square distribution. Okay, and so what do we know? We know that we have a critical value on the left side, which is 5.629. And then we also have another critical value at 26.119, which means that we have two critical regions. So here is a critical region. And then we also have a critical region here. Okay, so now we have our drawing of our chi-square distribution with our critical values. So now it says, will the researcher reject the null hypothesis and why? Okay, so the researcher will reject the null hypothesis if the test statistic falls in a critical region. Okay, so what is our test statistic? Well, our test statistic is 17.719. Well, somewhere around here is the test statistic at 17.719. So you can see here that it does not fall. So the test statistic does not fall in the critical region. So therefore, we do not reject the null hypothesis. So what we're going to say then is that the researcher cannot reject the null hypothesis.